Very good morning to all of you.
Good morning, ma'am.
Good morning. I'm audible clearly. Am I audible clearly? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Let us start. Now see, yesterday what we did, we decomposed the original table. This was the original table. We went in normalization. Now we decomposed this original table into two decomposed tables. Why we decomposed the table? Because we saw that this table had a lot of redundancy. Since redundancy leads to many types of anomalies, so we have decomposed this table. We have converted this table into higher normal form. What is the immediate? This table was already in 1NF. So what is the immediate higher normal form of this table? The immediate higher normal form is 2NF. Now, why it was in 1NF? Because each individual value present in each cell was atomic value. Atomic value means the value that is present in the table is logically inseparable. So we say it is atomic value since every column, every cell value is atomic. So the table was in 1NF. But since the table, though the table was in 1NF, we had seen that a lot of redundancy were there, which lead to update anomaly, delete anomaly, and insert anomaly. Now, so we converted the table to 2NF. How did we convert the table to 2NF? 2NF definition says that. Can anybody tell me what does 2NF definition tell us?
There should not
What
exist
does
any
2NF
partial functional
definition
dependence.
Partial dependency not.
Can you wait for just 1 minute? Let me bring the microphone, headphone, otherwise this headphone is creating a problem. Just 1 minute, students. Because I cannot hear you. Now, yes, who was responding? Who was responding? Who tell me what is the definition of 2NF? What does 2NF say?
There should not exist any partial functional dependence.
Hmm? There
Should not exist.
So this is the
There should.
definition. If anybody asks you what is the definition of 2NF, what you will say? You will say a complete definition. What is the complete definition?
Ma'am, no non-key is partially dependent on candidate key.
A relation will be in 2NF if it is
Already
already in 1NF and no non-key attribute is partially dependent on the candidate key. This is the complete definition. You have to say the relation should be in 1NF. Then only we can talk about 2NF. Okay. And then you will say that no non-key attribute should partially depend on the candidate key. Now, what is a partial dependency? What is a partial dependency?
Ma'am, subset of candidate key determines non-prime attribute.
That means if any non-prime attribute depends on a key attribute, what is a key attribute? Key attribute is a part of the candidate key. So if any non-key attribute on the right hand side depends on the part of the candidate key or key attribute, then we say it is a partial dependency. So 2NF doesn't allow partial dependency. Where a non-key attribute depends on a part of the candidate key doesn't allow. So we have to remove that. How did I remove it? I made SID-CT as one of the T2 tables attribute is SID-CT. And here SID PID quantity FD was a fully function dependent. Now it was not creating a problem, hence I kept it as it is in the table T1. Next, what I did, I was worried about status column, where to add status. I added status in the second table, that is T2 table. Why did I add status in the second table? Because I have to preserve, there are two criteria for decomposition. What are the two criteria? The two criteria are the decomposition should be lossless and the dependency must be preserved. So here, in order to preserve the dependency, if I add status here in T1 table, the dependency CT2 status, which was present in the original table, was lost. I was losing that FD, but dependency preservation says that I cannot lose any FD. Hence, if I add status in the T2 table, then I saw that CT2 status FD, I got it back. Hence, what I did, I added it in the T2 table. Now, how do I understand whether the table decomposition is lossless or lossy? I will ask it. Abhyast Kumar. Abhyast Kumar, are you there? Abhyast Kumar? Abhyast Kumar is not there. So I will remove Yes, Abhyast Kumar is not there. I am putting him in waiting room. Next. Ritesh Gupta. Ritesh Gupta is there? Ritesh Gupta? Ritesh Gupta is also not there. Sunny Kumar. Sunny Kumar, are you there? Sunny Kumar, are you there? Arnob Chatterjee? Arnob
Yes, ma'am.
Chatterjee?
Yes, ma'am.
Arnob Chatterjee, tell me how I will understand whether the decomposition is lossy or lossless. Protiti Ganguly? Protiti Ganguly,
Yes, ma'am.
tell me the answer.
Ma'am, yeah. Ma'am, the answer is it will be lossy or lossless if the common attribute among the two tables is a candidate key.
Candidate key of whom? Candidate key of at least One of the table.
At least one of the,
And
yeah,
the
at least
key
one of the.
At least one of the table. Okay?
Yes, ma'am. Yes, ma'am.
Good. Why students are becoming so unserious, I don't know. Because this subject is will be required throughout your life. Wherever you go, whichever industry you go, this subject will be required. And moreover, when you sit for your campusing, this is the subject that will be asked by every industry. More or less, every industry will ask you from DBMS. So why are you taking this subject so lightly? So the entering, I'm allowing everyone to enter the classroom and then you're gone. Now I will not allow anyone. Once the class has been started, it's 10:15, I will not allow anyone. Okay, now, whatever you said, Pratiti Ganguly said that the decomposition is lossless, we understood, because the common attribute, which one is the common attribute? SID is the common attribute, and SID is a candidate key of this relation. Which relation? T2 relation. So in the T2 relation, since SID is the candidate key, so I can blindly say that the decomposition is lossless. Hence, the decomposition is all right. Now, what I have to do is, I have to now check whether the T1 table is in 2NF, has been converted to 2NF, and whether T2 table has been converted to 2NF or not. Now, again, I will ask. Sneha Chatterjee. Sneha
Yes,
Chatterjee.
Yes, ma'am.
Tell me, T1, if you look into the T1 table, can you say whether T1 table is in 2NF or not? Just the T1 table. Can you understand whether the T1 table is in 2NF or not? Nilesh Patel.
Yes, ma'am.
Can you tell me whether T1 will be in 2NF or is in 2NF or not?
No, ma'am.
Don't know. That means you did not understand yesterday. If you had understood, you could have answered these questions. These are very easy questions I'm asking you. Shayuk Chakraborty. Shayuk
Yes, ma'am.
Chakraborty,
Yes, ma'am.
are you there?
Yes, ma'am.
You have a T1, is T1 in 2NF?
Ma'am, according to the definition of 2NF, ma'am, if it is already in 1NF, so ma'am, the attributes
We are
are
considering that it is already in 1NF because data set is not given to you and it is RDBMS. So we will say that since in RDBMS table is already in 1NF, I am assuming that the table is in 1NF. Okay. So the
Yes,
first condition is true. What about the second condition?
ma'am, the second
Of
condition
table.
is no, ma'am, no non-key is partially dependent on candidate key. Here the ma'am non-key is quantity, and they are, ma'am, here the full dependency on SID and PID.
Here in this table, T1 table, who is the candidate key?
Quantity. Sorry, ma'am, sorry, ma'am.
Candidate key.
No, SID and PID.
SID, PID combinedly. Don't say and. Say
Yes, ma'am.
SID,
Combined is
PID
a quantity.
combinedly is the candidate key. Now, quantity is a non-key attribute. And who are the key attributes? SID is a key attribute and PID is another key attribute. Quantity, a non-key attribute, depends on the full candidate key. So, what type of FD it is? Is it a partial dependency? No, it is a fully functional dependent, isn't it?
Yes, ma'am.
The non-key attribute quantity is fully dependent on the full candidate key. Is dependent on the full candidate key. So it is an FFT. Hence,
Yes, ma'am.
it is in 2NF. Okay?
Yes, ma'am.
Okay, mute yourself. Now another student will answer me, Shayan Roy. Shayan Roy,
Yes, ma'am.
are you there?
Yes, ma'am.
Acha, Shayan, tell me whether T2 is in 2NF or not. Whether T2 is in 2NF or not. Shagun Goel. Shagun Goel.
Yes, ma'am.
Shagun Goel, tell me whether T2 is in 2NF or not.
No, ma'am, it is not in 2NF.
T2 is not in 2NF. Why?
Ma'am, because ma'am, it is partially dependent.
Who
Ma'am,
is
city is
dependent on who?
ma'am, city is partially dependent on SID.
City is partially dependent on SID. How? Why? Who is the candidate key of this relation?
Ma'am, SID.
SID. So city is what? Key attribute or non-key attribute?
City is non-key attribute.
City is a
So-
non-key attribute and status is also a non-key attribute. Now city,
Yes, ma'am.
a non-key attribute. What is the FD here in T2 table? SID city. SID determines city.
Yes, ma'am.
City is a non-key dependent on SID. SID is what? A
SID.
part of a candidate key or the full candidate key?
Ma'am,
With
part
respect
of
to T2 table, no, with respect to T2 table,
Yes.
SID is the full candidate key. Just now you said that SID is the candidate key of T2,
yes, ma'am.
isn't it? So when city is dependent on SID, SID is the full candidate key, then it is no question of partial dependency. Partial dependency was present in the first table, original table, where SID was a part of the candidate key. But here, SID is the full candidate key, isn't it?
Yes, ma'am.
So it is a fully functional dependent. SID to city in the table T2 is a FFT. It is an FFT. So it is not partial. And what about city to status? Status is a non-key and city is also a non-key.
Non-key.
So it is also not
It is
creating a
2NF.
problem in 2NF. Hence the
Yes.
T2 table is in 2NF. Understood?
Yes, ma'am.
Shagun?
Yes, ma'am.
Okay. Next. So I found that many students, maximum majority of the students did not follow yesterday's class. Anyway, I have to continue whether you follow or not. But why you all don't understand when you don't follow? How I will come to know? I'm not having eye contact with you. How I will come to know that whether you're getting or not? And I teach you very slowly. I don't run always, isn't it? I speak very slowly and I teach also very slowly so that you can understand. But I don't know whether you tell me that you are not getting. Okay, next. So we found that T1 is in 2NF, T2 is also in 2NF. Hence, the table has been converted to higher normal form and these are the decomposed tables. Clear? Now what I have to do, let me add the data here. Why did I convert it into 2NF? What were the, let me just add S1 supplies the product P1 by which quantity? By quantity 10. Next, let me just copy this. So these are the products, and the quantities are 10. Okay, and this column is not there. So this was your data in the T1 table. And what about T2 table? SID, city, and status. So SID, who is the SID? S1. City of SID was Kolkata, and status of Kolkata was K1, the original table. And what else suppliers we have? We have S3 as a supplier. S3 as a supplier. Where does S3 stay? S3 stay in Mumbai. S3 stays in Mumbai. And the status of Mumbai is M1. And what else we have? S4 as another supplier. S4 as another supplier. S4. Where does S4 stay? S4 stays in Dhanbad. Stays in Dhanbad, and the status of Dhanbad is DD1. So suppose this is the data. Okay. Now we have to find out that the table has been converted to 2NF. The table, this table T1 is in 2NF, and this is also in 2NF. This is also, just right, is in 2NF. Now the problem that I was facing in the earlier table, why did I convert it into 2NF? Because I was facing some problem, lot of redundancy. Due to the redundancy, more updation was done, more insertion was done, and more deletion was done. What was more insertion? More insertion means, suppose I just said that a new supplier S7 stays in Durgapur and the status of Durgapur is G1. I could not enter this record because the new supplier has no product to supply. Now, if the new supplier has no product for the time being, so I cannot insert this record because I could not keep product as null. Hence, I was unable to insert the information that S7 stays in Durgapur and the status of Durgapur is G1. This is a meaningful, this is an information, it is required, it may be required by some application. But this information I was unable to insert because the supplier was not supplying any product and I could not keep product ID as null. Okay, but here you will see this was the insertion problem we were facing in this table. But when I have decomposed the table and I go back to this decomposed table, I now can insert a new supplier's record. I can insert the new supplier S7's record. S7 stays in Durgapur. And the status of Durgapur is G1. Although the supplier S7 is not supplying any product, still I could insert this record, which was I was unable to insert in the earlier table. I was unable to insert this, isn't it? It was not inserted. So it is. I was unable to insert this. But here, see, just see table T2, I have very smoothly, I have inserted the record about the city and status of S7 supplier, although the supplier S7 is not included in this table because the supplier is not supplying any product. So until and unless the supplier S7 supplies any product, I will not insert the record into this table T1. Okay, so insertion problem that I was facing in the earlier table has been removed here in the 2NF T2 table. Next, what was the deletion problem? The deletion problem was if a supplier has stopped supplying a product Suppose S1 has stopped supplying P1 product and status of let me take another S4. Suppose S4 has stopped supplying P1 product and the quantity. Okay. So what happened is I have to delete the full record of S4. It was unnecessary, more deletion I was doing, unnecessary deletion I was doing. I only wanted to delete that temporarily. Maybe S4 is sick or maybe S4 is not well for a few months. So the S4 supplier has stopped supplying the product P1. I only wanted to delete this, but I could not, I was unable to delete only P1's information, P1 and 14, these two records, these two data, because I could not keep product as null. Hence, I had to delete the full record if I wanted to delete the product information of S4. Now, deleting the full record means for the city and status of S4 was also getting deleted, but that was unnecessary deletion. So here it is possible. S4 has stopped supplying the product P1. So I will simply delete it from here. Although the city and status of S4 supplier is still available. Here. Okay. Now the question is so some of the anomalies that I had seen in the earlier table has been removed when I converted the table to 2NF. But is any redundant information present in this T1 table? Does the T1 table have redundancy? No.
No, ma'am.
Yes, can anybody tell me? T1 has redundancy or not? No. What happened? Does T1 have any redundant information? Unnecessary information?
No, ma'am.
No. Why?
No.
No, ma'am.
S1, 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 S1. So many repetitions are there. 10, 10, 10, 10 repetitions are there.
But in T1, SID, PID combinedly are the candidate keys.
So what?
That's why it's not redundant.
1 minute, just hold. My daughter is shouting so much. 1 minute. Okay, let me see. Our time is very less. I'm stopping the sharing. Rejoin again. Okay. records of few suppliers, even if they don't supply any product, or we could have also deleted information very smoothly. But my question was T1, is T1 having redundancy? I will say no, T1 is not having any redundancy. Why it is not having redundancy? Because here, although redundancy doesn't mean repetition, isn't it? I said redundancy doesn't mean repetition. Here S1, 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 S1 is repeated many times, but it is necessary for repetition. Why it is necessary? Because supplier S1 is supplying multiple products. So everywhere, wherever, suppose if supplier S1 supplies 100 products, I have to repeat S1, 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 S1. Who is the supplier who is supplying the product? S1. So I have to repeat it. It is not unnecessary. I have to do that. Otherwise, the meaning will change. Similarly, P3 is repeated here. I have to repeat P3. Repetition is not redundancy. It is necessary information which is repeated, because S3 also supplies P3, S1 also supplies P3. So I have to write it. I have to repeat it. I cannot keep it null. And quantity can be repeated because maybe multiple suppliers are supplying the same quantity of product. So nothing is unnecessary information stored here. Redundant information is not present in the T1 table. Is it clear? Now let us come to T2 table. Let us come to T2 table. In the T2 table, what is there? Is redundancy present in the T2 table?
No, ma'am. No, but yeah, there could be.
No, actually, the instance that I have added, wait, let me increase, let me add some more records here. Suppose S7 is a supply, S5 is a supplier. 1 minute, let me add a record. S5 is a supplier, supplies the product P1. This was already present. Let us assume this was present. S5 stays in Kolkata. A supplier can, multiple suppliers can stay in a single city. Okay. So in Kolkata, there can be other suppliers also. In Delhi, there can be other suppliers also. So the status of Kolkata is K1 and the quantity is 12. Let me add another record. S6 also stays in Kolkata. P2 also stays in Kolkata. And the status of Kolkata is K1 and the amount of supply is 30. So these two records needed to be added there. So S5 supplies which product? S5 supplies P1 by how much quantity? 12. And the other row is S6 supplies which product? P2 by how much quantity? 30. Where does S5 and S6? So I will add the records here also. So S5 stays in Kolkata. And what is the status of Kolkata? K1. S6 is another supplier who also stays in Kolkata. And the status of Kolkata is K1. Now tell me, and there can be other records also. Maybe somebody stays, more than one supplier stays in Dhanbad, Durgapur. So these records are there. I have added a very small table. I have shown you a very small instance. Now my question is, T1, there was no redundancy. Just now I explained you. What about T2? Is redundancy present in T2 table? Is redundancy present in T2 table?
CT and status attribute are repetition are there.
Repetitions is not redundancy. Please don't say repetition. It can be repeated. Here also I have repetitions, isn't it? P1, P1, P1. but it was necessary information. I had to repeat it. And
But in city and status, ma'am,
just
is
see,
it
if I
if you
don't
go?
repeat it, yes, 1 minute. If I don't repeat it, suppose I'm not repeating P1 and here also I'm not repeating P1, I've kept it null. So what is the problem? S5, what is the product supplied by S5 information is lost, isn't it? I have to repeat it. But if you look into the second table, T2 table, here also we have repetitions. Kolkata, 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 K1, K1, K1. These are the repetitions. But this is unnecessary repetition. Why? Because if I don't write K1, suppose if I don't write K1 for this one, Kolkata, then am I losing the information that what is the status of Kolkata? No, I can find it out. From where you can find out? You can find out from the very first row that the status of Kolkata is K1. But still, so if I don't mention these, I don't repeat these, it is not that we are losing the information. But here, if I don't repeat, then I am losing the information. If I don't repeat, just now I showed, if I don't repeat P3, then I'm losing the information that S1 is also supplying P3 product. But in this case, table T2, the repetitions that was present is redundant because, why redundant? Unnecessary. Because even if I don't keep the status of Kolkata in the successive tuples, I could find out from the very first row that the status of Kolkata is K1. So it was not lost. The information will not be lost if I don't mention them. But still, I have mentioned everybody that Kolkata K1, or Delhi T1, Dhanbad T1. These informations are redundant information we are storing in the tuples. Okay, so redundancy, although the table T2 has been converted to 2NF, still redundancy is there. Still redundancy is there. And what did I say? If redundancy is there, then what will happen? Anomalies. What are the anomalies? Insertion anomaly, deletion anomaly, and updation anomaly. So if the status of Kolkata has changed from K1 to KK1, then everywhere, suppose it's a big table, wherever Kolkata is there, I have to update, I have to do more updation. I have to go on updating all those status where K1 is there. I have to update it to KK1. And by mistake, if I update the 5 records and the remaining records I by mistake or due to some other reason I did not update, then what will happen? What will be the table? The table will be inconsistent. Data will be present in the table. Somewhere, some tuples will have K1 as the status of Kolkata and some tuples will have KK1 as the status of Kolkata. So when a person tries to query that what is the status of Kolkata, what it will show. So it is an inconsistent data which is not possible in the present scenario. According to the problem, a city can have only one status, not more than that. So it was an inconsistency due to redundancy. Now what I have to do? What is the solution? I have to convert it into higher normal form. How I convert it to what is the immediate high normal form of this table? The immediate high normal form of this table is 3NF. So I have to convert this table to 3NF. How do I convert this table to 3NF? So write 3NF and write the definition. A relation is in 3NF if it is already in 1NF. A relation is in 3NF if it is already in 1NF and no non-key attribute is transitively dependent on the candidate key. No non-key attribute is transitively dependent on the candidate key. Written, a relation is in 3NF if it is already in 2NF and no non-key attribute is transitively dependent on the candidate key. No non-key attribute is transitively dependent on the candidate key. Written? Everybody has written?
Yes, ma'am.
Yes,
or
ma'am.
no? All of you have written this?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay. Okay. Now, what is the meaning of the second line, second condition? What is the meaning? I said no non-key attribute. First of all, tell me who are the non-key attributes of this T2 table? Who is the candidate key? Candidate key is
SID.
SID. So, SID is a key attribute. Sorry, it is a candidate key itself. And who is the non-key attributes? Who are the non-key attributes?
City and status.
City status.
Non-key
And
attributes-
status.
Non-key attributes are city and status. Now, if I apply an axiom in these, so how many FDs we have? One is SID to city and another one is city to status. If I apply some axiom here, can I get a new FD? What is a new FD? Transitive.
SID to
If
status.
I apply a transitive,
SID to status.
can I get SID to status? SID to status I'm getting. Now, this one is here. If you look into this new FD, here, right hand side is a non-key attribute. Understand it carefully. Right hand side is a non-key attribute, and the left hand side is what? A
Candidate key.
candidate key. Candidate key. Now, a non-key attribute is dependent on the candidate key via which rule? Via which rule? Via
Transitive.
which rule we got this new FD?
Transitive.
Got this rule new FD via transitive rule. Isn't it? No, but 3NF say that no non-key attribute should depend on the should transitively depend on the candidate key. Transitively depend means no non-key attribute depending on the candidate key should be got, such an FD should not be got via transitive rule. But here we got such an FD where a non-key attribute is on the right hand side dependent on the candidate key via transitive rule itself. Okay, so I will say the relation is not in 3NF. Now, here I have given two FDs. Here there are only two FDs in the T2 table, so it became very easy to understand that SID to status is there. But sometimes you will see when the list of FDs is very large, then it is not very easy to find out what are the transitive dependencies present here. Maybe it is not, you may find out, or if you are unable to find out, there is a short trick. What is when such, the trick is when such FD will be derived where a non-key attribute will transitively depend on the candidate key, will be got via transitive dependency. Such FD will be got only when there is a dependency, given dependency, where you find that a non-key is on the left hand side and the non-key is on the right hand side. So if there is a non-key relationship present in your table, then you can be blindly sure that there is a FD where a non-key attribute will depend on the candidate key, and such an FD will be got via transitive rule. Understood what I tried to explain? What I said? 3NF
Yes,
says
ma'am.
that the relation has to be in 2NF, and what else? No non-key attribute should transitively depend on the candidate key. So here in the two FDs given on T2, we found just now that SID to status is a new FD, and we got it via transitive by applying transitive rule on these two FDs. Now, so we will say this relation is not in 3NF because such an FD is got. Now, I said there is a trick that if you find sometimes when the list of FD is very large, you can apply this, that if there is a non-key relationship in your table, CCT is a non-key attribute, status is also a non-key attribute. So both are non-key on the left side as well as on the right side. If such an FD exists in your table, non-key relationship is there, then you can blindly be sure that there is a FD where the right hand side there will be a non-key, and left hand side there will be a candidate key, and such an FD will be got by a transitive. Clear? So when there is a non-key relationship, the T2 table, the table will not be in 3NF. But in the exam, when you will write, don't simply write non-key is there, so the table is not in 3NF. No, you have to write the full thing, whatever I explained. Since there is a non-key relationship, so I will get this FD. You have to write the complete thing. Okay, otherwise you won't be getting marks. Now, who is creating the problem? The problem has been created by this non-key relationship. Since it is there, so the full problem is there. Hence, what I have to do, I have to convert the D2 table to 3NF. And while converting, how I will convert? I will decompose this table into two tables. So how I will decompose this table D2 into two tables? I have to remove this, where is that? This dependency, city status. So I will create a table. I will create a table. Time is in a 10 minutes. Okay. I will create a table where you will tell me, okay, now what will be the table? Let the name of this table be T21, and another table will be T22. This is T22. Now in this table, which attributes I will be keeping? Who was creating a problem? City2 status. So I will simply remove city and status here. And what about this table? What I have to keep in the second table?
SID city.
SID city. Let me check whether it's correct or not. Let SID city. Now, what are the 2 points? If I do this sort of decomposition, then whether it is correct or not, you have to check. So it may not be correct. Maybe we have to add some other attributes. Let us check. What are the 2 rules? The 2 rules are lossless decomposition and dependency preservation. First of all, dependency is preserved or not. Let us check. What were the dependencies present here? City to status, SID to city. SID to city is got here. SID to city. City to status is got here. City to status. What about SID to status? SID is present in this table. Status is present in that table. So SID to status we are not getting directly. But the thing is, I cannot lose any dependencies, isn't it? So in the F plus, there will be obviously SID to status FD. Now what I have to do, I have to bring that FD. Now when you do F plus of these two together, what I get it back, isn't it? When I combine these city to status and SID to city and make the set S, and then if I find out F plus, then I can get SID determining status via transitive rule. So the dependency is not lost. Ultimately, when I will merge these FDs and I will apply axiom, I will get the SID to status FDs. So it is not lost. Hence, dependency is preserved. Now, what about lossless and lossy decomposition? Is the decomposition lossy or lossless? Who is the candidate key of this relation? T21. Who is the candidate key of T21?
Ma'am, city.
City, because city is determining status and city will determine itself. So city is an attribute which is determining all the attributes of the relation. Hence, city is a candidate key. Who is the candidate key of T22? SID. Why? Because SID determines SID, SID determines city. So it is determining all the attributes of the relation. Hence, SID is the candidate key of this relation. Now, what I was saying? Yes. Is it lossless or lossy? It is lossless. Why it is lossless? Because who is the common attribute? The common attribute is city. And the common attribute is a candidate key of this ring of at least one relation. Who is that one relation? T to 1. Hence, the decomposition is lossless. Now, the third question is T to 1 converted to 3NF actually? Is it in 3NF? You have to check last of all. So yes, it is in 3NF. Why it is in 3NF? The only FD that is present in T21 is what? CT2 status, when CT is a candidate key. Is there any non-key relationship? No. So I can say it is in 3NF. Again, go to T22, CT2, sorry, SID to CT. SID is a candidate key. So no question of non-key relationship. Hence, it is in 3NF. Okay. So now you will see what was the problem in 2NF. The Kolkata status was repeated many times, isn't it? It was unnecessary to repeat the status of Kolkata many times. But if you look into this table, Kolkata city, Kolkata status is K1. I will only write once. City Durgapur. Status is DG1, most probably. I will only write one. So no repetition, no redundancy. I'm not writing Kolkata K1, K1, K1. I'm not writing that. And which supplier stays in which city? S1 stays in Kolkata. S2 stays, suppose in Kolkata. Then is it repetition? Is it redundant? No, it is not redundant. No, this repetition is there. Because I have to keep Kolkata, Kolkata. Because if I remove this, then where does S2 stay? That information is lost, isn't it? I cannot find out from anywhere else. So where maybe a supplier can stay in more than one city. Sorry, a city can have more than one supplier. So the supplier S2 is also staying in Kolkata. That is not a redundant information. Hence, T22 is no redundancy is there. Similarly, in T21 also no redundancy is there, and the tables are converted to 3NF. Okay, so let me all of you write your roll number in the chat box. Only few students are serious, others are not at all serious. Only 32 participants have given their attendance. Just see. 41 participants are there. Out of those, only 33 participants have entered their attendance. Others are not there actually. Okay, let me stop it. Thank you, everyone.